Hello and welcome. Today I'd like to review an M2M connection to an M-Power 2210 amplifier system. This demonstrates the connectivity and the command set used to control the amplifier. To start, we want to make sure that we understand the target IP address of the system that we're trying to connect to. And I have here an emulation of the front panel screen using the remote web GUI. Similar command layout on the front panel LCD. If we connect using the administration tab, we can see the IP address that the machine is currently set to. And we want to establish an M2M connection using that address. The first thing that we want to do is make sure that the connection between the PC and the target device is established. So we'll use the Windows command prompt to do so. And to do that, we'll use the ping command and type in the target IP address as shown. Hitting enter allows you to see whether the connection is established, and the expectation is to see reply messages as we've seen here. This guarantees the connection between the host PC and the target device is established. And if you do not receive the reply messages, you'll need to check the connections under your Windows desktop settings to see the network connectivity settings. You want to check there first to make sure that there are compatible settings between that and the target device. Since we have gotten a successful connection here, we can close or terminate that application. And the next step would be to open up a TerraTerm application. This is allowing console to be able to send the M2M commands to the target device. In this case, we choose TerraTerm as it's one of the common applications that we use in-house at M-Power, but there are many other terminal applications that are compatible, as well as you can develop your own host application. To establish a connection, we're going to establish a TCP/IP connection to the host address. In this case, it's currently set correctly. Under services, we want to change from SSH to other, and we want to set the port address to 3000. Our target device accepts M2M connections at port 3000. We'll apply that by saying OK. And then the next step is to set up the terminal. So we do that by clicking Setup, Terminal. And here we want to set the new line characteristics under Transmit to have both a carriage return and line feed. We also want to turn on Local Echo. We apply that by selecting OK. Now the terminal is actually ready to accept commands. One of the first things that we'll notice is that in the web GUI, we've changed from control mode remote to M2M, and it's disabled the commands locally from the web GUI because we're in an M2M connection mode. This is part of the arbitration between the local GUI, the remote GUI, and M2M. M2M has the highest priority. The first thing we might want to do after establishing a connection is find out what mode the system is in. And from the web GUI, we can already tell we're expecting an online command response. And in this case, we just have the system set at low power for this demonstration, with an input very low and an output set at around 60 dBm, just for illustration. To type the mode query command, type M ? And it echoes back the command as well as the status, which in this case is representing online and in manual gain mode. The commands are non-case sensitive, so you don't have to use capital letters. You can interchange between lowercase and uppercase. In this case, if we wanted to see what the forward power was, we can type in PF, and this returns a value of 60.55 dBm. And we can see that that's pretty much what the web GUI is showing us at the output power. For P-in, we can do the PI command, and if we hit enter there, we can see that that returns minus 13.62, which is very close to what we have on the web GUI as well. For power reverse, we do PR, and this is currently reflecting a minus 70 dBm, and it's just because the power reverse is so low that it's below the measurable value. Minus 70 is the lower value that would be returned in that case. To change the gain of the system, we use a command called LM. And LM, just to see the current setting, which we're expecting to return a 100%, we'll do LM query, and we can see the return is 100. The gain is set in units of percentage from 0 to 100%. 100% is maximum gain of the system, and 0% is the minimum gain for the system. There's about a 30 dB range between 0 and 100%. So in this case, to set the gain, we use the LM between less than and greater than signs. We pass the desired set point. In this case, if we want to set it to 50%, we'll type in 50 and hit enter, and we'll see that the gain on the remote GUI is now showing me 50%, and we can see the forward power went from our nominal 60 dBm to about 45 dBm. If I again increase the gain, do LM 100%, we'll see that the settings have returned back and restored to our original settings of 100%, and our forward power is now reading around 60 dBm as it did before. Some other commands that may be of interest is fault status, and the major one for that is show status, and that's the SS command. And this command's response is a little unique because it actually comes back indexed from each component within the system. In this case, you can see that the indexes are 1 for booster 1 and index 2 for booster 2. And we have index 100, which is indicating the system controller. We've reserved indexes 1 through 99 for all of the booster elements within a system, and then the central controller address or index will be 100. The top level system status is reflected by the show status at index 100. And our philosophy here is that the protections that are done at the top level are set tighter than the ones that would be found inside the booster. So we expect that for example, if a VSWR condition occurs, it will occur at the top level of the system ahead of the last resort protection that is set up in the booster. So depending on how severe the condition may be, you may only get a top level fault flag set, as opposed to having a lower level booster flag set for the same parameter or fault condition. A breakdown of these commands can be seen in the command set that is provided with the unit, and I'll pull that over here. We can see for show status, I'll get to that section of the document here. We can see that there is a breakdown for each one of the fields within the return messages. And again, for the multi-drawer system, you're going to have this indexed response. For the controller level, you can see that there are 2 fields ahead of a status flag field. The first digit, position O, is for status of online standby or cold standby. The next field is whether the system has faults or no faults. And the last 2 digits field is a breakdown of a status flag for each one of the individual fault flags. You can have multiple flags set simultaneously, and you can see there's a weighting to each one of the flags here. The booster level flags are similar. where it has status fields, and then it has a 2-digit fault flag field, and then a lower level, module level breakdown to show specifically what module within the system is faulted. And the breakdown for each one of those fields corresponds here. So we can see that the first field is for online standby or cold standby. Now the boosters themselves are going to be in online mode all the time, and the top level status flag is going to change only for the top level for online and standby. The system will indicate faults either at the system level or a module level. So within the booster itself, we call it a system level fault or a module level fault, or there's no faults existing. The next parameter or field is the input field, and this is going to say whether there's input above the threshold level or if the level is too low. And the next field shows a high level module status for the booster. And the last 4 digits break down each individual module within the system as applicable. If we were to take a look at some of the other commands in this document, we have the MO command that can be used without the parameter, which means that it goes online indefinitely, or we can actually pass a timeout. If we pass a timeout between the greater than and less than signs, it will stay online for the duration in the number of seconds entered. So in this case, if we look at the example, we have 7200, which would stay online for 2 hours, then return automatically to standby. This can be useful to minimize the overhead if you're trying to make a transmission for a certain duration and then cycle back to standby thereafter. MS is a standby command. This puts the system in hot standby where the power supplies are still on. Cold standby turns those power supplies off as well. So for power savings, if you want to enter cold standby, that cycles down the main power supplies as well. For power management in the system, you have the level control manual gain that is from 0 to 100%. LM query returns the current value. Fault clear is actually used to clear any latch faults within the system. This can be sent at any time to clear any of the fault flags that are showing in the SS status message. And the SS status message will automatically push from the device when a fault event occurs. So you will be getting that auto pushed back from the offending element within the system, and you may get one or more of the elements reporting the fault flag. The network close is something I'll demonstrate toward the end of this lesson, which will return from the M2M session back to the prior control mode. So if you were in remote mode, it will return back to the remote web GUI. If you were at the local panel, it will return back to the local panel control. We also have some administrative queries, such as the ID of the system, serial number, software version number can be all queried from the machine. The status information regarding the detector type, in this case, you'll be looking for in peak mode will be peak slow detector type for this pulse system. And you can also query the mode, as we've demonstrated before. In this case, the modes that are of interest for the pulse system is for MGC only. We don't have enabled ALC or AGC options for the 2210. We've covered the show status message. And the last section here indicates the monitoring. We've shown already how to measure forward power, and we show how to measure the P in, P reverse, and there's also a VSWR calculation that's done real time as well that can be queried. The last command is temperature, and this is also an index command. So if we were to demonstrate that, if I type in T ? You'll see that the booster number 1 returned a status of max temp at 37 degrees Celsius and an internal ambient temperature of 31 degrees Celsius. With the power being backed off so low, these are very low skew between the internal ambient and the maximum temperature. As we bring the system more toward full power, those values will increase. The next command that you see, or next response you see, is from index 2, and this is indicating that it's coming from booster 2, and its max temperature is 36 degrees, and its internal ambient is 30 degrees. To demonstrate the network close, I'll bring back the remote web GUI, and this is the screensaver, so I'll just press to resume. You can see that we're currently in M2M control mode, and the commands are disabled. We're going to terminate the M2M connection by typing in network close, NC, and you'll see that the terminal window will disappear, and the system will return us back to the remote web GUI control mode, and we will now regain control of the unit using the web GUI. So the commands are no longer disabled, they're available for use. This concludes the instructions for establishing an M2M connection and sending commands via terminal application to the target device, which is an M-Power 2210 amplifier system. Thank you.